So take down this problem. Take down this problem. Example 13.33. Write down the question. In a circuit, the applied voltage is 100 volts and is found to lag the current of 10 ampere. After writing the question, inform me. I will discuss about the problem. Okay, have you written the question?
Yes, sir.
Okay. See, in the problem, he is saying that voltage is voltage. Right on. In the problem, voltage is lagging the current. In the problem, voltage is lagging the current, which means current is leading the voltage. Which means current is leading the voltage. If current leads the voltage, what is the circuit? If current is leading the voltage, what is the circuit? RL or RC?
RC.
RC circuit. Well done. If current is leading the voltage, circuit is capacitive. Circuit is capacitive. Your circuit is capacitive. If the circuit is capacitive, power factor is leading or lagging?
Leading.
Leading. In capacitive circuit, power factor will be leading. In inductive circuit, power factor will be lagging. So in this problem, since the circuit is capacitive, first bit is power factor is leading. First bit is power factor is leading. Now come to the second bit. What is the power factor formula? Cos phi. What is phi given in the problem? $30. What do you mean by phi? Anyone? What do you mean by phi? Write down. Phi is the angle in between voltage and current. Phi is the power factor angle. Phi is called power factor angle in between voltage and current. In between voltage and current. In between V and I. The angle is called phi, power factor angle. But power factor is cos phi. Phi is called power factor angle and cos phi is the power factor. That is the second bit. Write down the second bit. Cos phi. We are getting 0.866 lead. Because it is capacitive circuit, that's why you are taking power factor as leading. What is the third bit? Is the circuit inductive or capacitive? Circuit is capacitive because current is leading the voltage. Reason is current is leading the voltage. That is the third bit. Now come to the fourth bit. Active and reactive power. Now see here, active and reactive power. Your active power is P is equal to VI cos phi. Okay. What is V given in the problem? Has I given V in the problem?
100 volts, sir.
100 volts.
100. What is the current given in the problem?
10 amperes.
10 ampere.
Yes, sir.
Okay, 10 ampere. What is cos phi? Phi is 30. This is the active power. This is the active power. And reactive power Q is VI sin phi. You will get 500. The unit is volt amp reactive. The volt amp reactive. And S is equal to VI. They have not asked the problem. They have not asked the apparent power in the problem. They have not asked. If you want to calculate, you can calculate. Apparent power is S. S is the apparent power or total power. S is called apparent power or total power. S is called apparent power or total power. They have not asked in the problem. If you want to calculate, you can. So that's all about the problem. Now we'll go to the next problem. Take down the next problem. A tungsten filament bulb rated at 500 watts, 100 volts to be connected. Write down the problem. After writing the problem, inform me. Have I written the problem?
1 minute.
Okay.
Completed.
Completed? Okay. See here. A tungsten filament bulb this is the bulb. This is not inductance. This is the bulb symbol. Inside the bulb we are having resistive filament. Inside the bulb we are having resistive filament. This is the resistive bulb. Okay. What is the power they have given? What is the power in the bulb they have given?
500 watts.
500 watts. 500 watts means W. W is watts. P is equal to 500 watts. If it is not visible. P is equal to 500 watts. I'll write here. P is equal to 500 watts. And what is the voltage across the bulb?
100 watts.
100 volts. And he is connecting this bulb. One capacitance they are connecting in series with the bulb. And they are connecting across how much voltage?
200 volts.
200 volts.
Change it to 220 volts. In your problem, change it to 220 volts. In the answer, they have taken 220. In the problem in question, take it as 220 volts. In the problem, they have given 200, change it to 220 volts. 220 volts, 50 hertz supply. Now he is asking us to determine how much value of capacitance we have to connect in series with the bulb so that the bulb will glow brightly. So I am taking the voltage across capacitance as VC. Therefore, I will write V is equal to VB. VB is the resistance. Inside the bulb we are having resistance. Minus J VC. For capacitance I am taking it as VC. Okay. Now draw the phasor diagram for this. VB is the resistive part, real part. VB is the resistive part, real part. And minus J. Minus for capacitance negative side. This is VC and this is your V. Your phi is negative because here you are getting negative sign. Your phi is negative. Now we know V 220. VB we know. Therefore, hypotenuse square is equal to side square plus side square. Hypotenuse square is equal to side square plus side square. V is 220 volts. VB is your VB is 100 volts plus VC square. Now calculate the value of VC. Calculate the value of VC. You'll get this. VC is equal to 196 you'll get. What is the current flowing in the bulb? What is the current flowing in the bulb? Power in the bulb they have given. Power in the bulb is VV into I cos phi in the bulb. Your bulb is the resistive part. What is the angle in between voltage and current in the resistance? In resistance, what is the angle in between voltage and current?
Phi.
0. In resistance, I am asking because your bulb is resistance. See, your bulb is the resistance. In resistance, angle in between voltage and current is 0. Angle in between V and I is 0 in resistance. In the bulb, I am saying. In the bulb, I am saying. So here, phi B is the angle. Your phi B is the angle in between VB and I. Your phi B is 0. Your PB is 500. VB is 100. I cos 0. Cos 0 is 1. Therefore, I is equal to 5 ampere. Your current in the bulb is 5 ampere. Your current in the bulb is 5 ampere. Suppose if current in the bulb is 5 ampere, what is the current in capacitance? What is the current in capacitance?
5 amperes only, sir.
5 ampere. Because in series current will be same. Whatever the current flowing in the bulb, the same current is flowing in the bulb also. And I know VC is equal to I into XC.
Sir, VC value I got it 184.3, sir.
No, sir. 195.95.
Please take it from, because we have taken, okay, 220 you take here. Don't take 200. If you are taking 200, you'll get 184.47. Because I have told in the problem, change it to 220. Change the value to 220. This is 220. Okay,
Yes,
196.
sir, I changed.
In the problem, change this value to 220. 200 they have given, change it to 220. That is, they are asking C value. C is, SC is equal to 1 by omega C. SC is 1 by omega C. That is 5 into 1 by 2 pi fc. Frequency they have given in the problem 50. Tell me the value of C. you will get this value, capacitance. C is 81 microfarads. Then power factor. Cos phi is equal to VB by V, 100 by 220. Leading. That is from the phasor diagram you will get cos phi. Your phi B is the angle in the bulb. Phi is the power factor angle. Your phi B is the angle in the bulb. Your phi is the power factor angle. Leading, because it is capacitive circuit, that's why power factor will be leading. So if you connect 81 microfarad in series with the bulb will glow brightly. That is the conclusion. Your conclusion is, if 81 microfarad is connected in series with the bulb will glow very brightly. Okay, next problem. Any doubts?
Yes, sir.
Tell me. Tell me. No doubts? Okay.
Nawaz.
See, this is the problem. This is the solution you have done. Next, we'll go to the next problem. Take down the example. Don't write now. Note down example 13.38. This is an assignment to you. This is an not this one. Example 13.39 is the assignment to you. Example 13.39 is the assignment to you. In the previous classes, we have done in series with the bulb, we have connected resistance and inductance. Today, we have done by using capacitance also. So, the three combinations R, L, and C. This is an assignment to you. Example 13.39. Note down the number. And if you want page number 529. Already I have shared this soft copy to you, this textbook soft copy. Example 13.39, page number 529 is an assignment to you. Next topic, series RLC circuit. Right on, heading series RLC circuit. Series RLC circuit. Series RLC circuit. Heading series RLC circuit. Okay, listen here.
Sit by myself, talking to the moon.
Okay, listen here. Series RLC circuit, R, L and C are connected in series. We are connecting R, L and C in series. Now here, we will write the formula for it. I is the current. Whatever the current flowing in R, same current will flow in L and C. I am taking the impedance Z is equal to R plus J XL minus J XC. For inductance, you will get plus. For capacitance, you will get minus. R plus J XL minus XC. That is equal to R plus JX. Where X is equal to XL minus XC. X is called net reactance, right? X is called net reactance. X is called the net reactance. X is called net reactance. X is called the net reactance. When X is positive, when you can say X is positive, if XL is greater than XP, your X is positive. Suppose if XL is less than XP,
X is negative.
X is negative. Suppose if XL is greater than XP, your circuit is mostly inductive. If your XL is greater than XP, your power factor will be lagging. If XL is greater than XP, it is mostly inductive circuit. Power factor will be lagging. Suppose if XL is less than XP, your capacitance is greater than inductance. That is, it is capacitive circuit and your power factor will be leading. Now I will discuss two cases. One is XL greater than XP and the one XL less than XP. See here. Case 1. Case 2. XL greater than XP. XL less than XP. Then Z is equal to R plus J X. Here Z is equal to R minus J X. Because XL is less than XP. Now I am drawing, see here. Now I am taking XL is equal to, let us assume that for example 5 ohms, XC is 3 ohms. Let us assume XL is 5 ohms. Z is equal to R plus J XL minus XC. X is XL minus XC. R value is taken on the X axis. XL is 5 ohms. Your XL is 5 ohms. I am taking 5 centimeter line. Your XC is 3 ohms. I am taking 3 centimeter line. XL 5 centimeter because positive. XL is positive in the upward direction. XC is negative in the downward direction. See, XL is 5 centimeter. XC is 3 centimeter line. Now what is XL minus XP? What is XL minus XP? 5 minus 3,
2 ohms, sir.
2 ohms. This is your X value. This is your XL minus XP, that is 2 ohms. Now Z is the resultant of R and X. Z is the resultant of R and X. Z is not the resultant of R and XL. Z is the resultant of R and X. X is equal to XL minus XP on the positive side. Now come here. XL is equal to 3 ohms. XC is equal to 5 ohms. I am taking. Now Z is R is taken on the X axis. See here, I am taking R on the X axis. XL is 3 ohms. XL is 3. Your XC is 5 ohms. Now 3 minus 5, how much?
-2.
Minus 2. Okay. This is your X in the downward direction. I am taking in the downward direction, minus 2. Minus 2 means negative Y axis. Minus 2 means negative Y axis. This is your Z. Z is the resultant of R and X. So like this, these are the phasor diagrams. Case 1 and case 2. If XL is positive, if XL is greater than XP, it should be in the upward direction, positive direction, your Z. Suppose XL is less than XP, it will be in the downward direction. These are the phasor diagrams. Remember this. Z is the resultant of R and X. Z is the resultant of R and net reactance. If you are having doubt, you can ask me in this. Okay. Now we'll do one problem. Take down this problem. Example 13.43. Write down the question. After writing, inform me. I'll start the solution.
Done, sir.
Okay. See you. Now they have given R is equal to 20 ohms. Draw the circuit. R is equal to 20 ohms. L is how much they have given L? L is 0.2 Henry and C is
100 microfarad.
100 microfarad. Is connected across 220 volts, 50 hertz supply. This is the data given in the problem. This is the data given in the problem. He is asking us to determine the impedance. Z is equal to R plus J XL minus XC. This is the impedance. For inductance plus, for capacitance it is minus JXC. First I am determining XL. XL is equal to omega L. Omega is 2 pi F. That is 2 pi 50. L is 0.2. They have given 0.2 Henry L value. Calculate.
$63.
63 ohms. We'll get 63 ohms. XC is 1 by omega C. Reactance. This is capacitive reactance because I want Z. If you want Z means you have to determine XL and XC. 1 by 2 pi frequency is 50. Capacitance is 100 into 10 power minus 6. You will get 32 ohms. Right down. Now tell me what XL is greater than or less than XC?
XL is greater than XC.
Okay, if XL is greater than XC, circuit is inductive or capacitive?
Inductive.
Inductive.
More inductive. Right down. Since XL is greater than XC, your power factor will be lagging. Since XL is greater than XC, your power factor will be lagging. Since XL is greater than XC, your circuit is mostly inductive. In inductive circuit, current lags the voltage. In inductive circuit, current lags the voltage. That's why your power factor is lagging. This point you remember. In problem they are not asking, but you have to remember this point. Now convert this impedance to polar form. Convert this impedance to polar form. Convert this impedance to polar form. How much?
Sir, magnitude is 36.89.
Okay, approximately 37. In your textbook, they are giving it as 37. Okay. And angle?
0.99, sir.
Angle. I think your calculator is in the
52.
57.17.
57.17. 0.19 you had told. Your calculator change the mode to common mode. It is in radians, I think. Keep your calculator in degrees. Go to mode and select degrees. You are getting wrong answer. Reason is because your calculator is in radian mode. Keep your calculator in degrees mode. Keep your calculator in degree mode. One student told that it is 0.19 something. If your calculator is in radian mode, you will get wrong answers. Keep your calculator in degree mode. Go to mode and change the settings. Your angle is phi is equal to 57.17. Whatever the angle you are getting for Z, that is your power factor angle, 57.17. Okay, we have calculated the impedance. Now I want to calculate the current. See, current I is equal to, what is the formula?
V by Z.
V by Z. Your V is 220. They are not given any angle, it is 0. And Z is 37. $57.1. Okay. And I is equal to, what is 220 by 37? If angle comes to numerator, it becomes negative. If angle 0 minus 57.17, 0 minus 57.17, it is minus 57.17. This is your current. Next he is asking in the C bit voltage across resistance VR, VL and VC. He is asking voltage across resistance VR, VL, VC. VL is equal to I into R. VR is equal to I into R. VL is equal to I into XL. I into XC. In series, current will be same. In series, current will be same. What is XL? 63. Your XL is 63, XC is 32. In the third bit, he is asking voltage across resistance, inductance, and capacitance. What is the value of VR?
120, sir.
120 volts. VM
378.
378 volts. This one
192.
192.
next he is asking power. Power in watts. The unit of P is what? P is equal to VI cos phi. R I square into R. Any formula you can take. VI cos phi. V is 220. I is 6 cos 57. What is the angle? 57.17. Your phi is 57.17. Z angle. Whatever the angle you are getting for Z, that is your power factor angle.
715.60.
How much?
715.63.
715.63. Okay. 715.63. Are you getting same answer with this formula? I square R. I square is 6 square. R is 20. Verify it.
720.
720, sir.
720 what? Then here also you have to get 720. Verify it.
Sir, we are getting only 720 back.
How much?
720.
Here also.
No, sir. There we are getting 715.63.
715.63. I think it is exact. Your current is not exactly 5.8, I think. Okay. Approximately you have to get the same answer in power. We'll verify that. Okay. Next, what is the last bit? Power factor. Cos 5. Cos 57.17.
Zero 0.54.
0.54. In the problem, he is asking only active power or something else. What he is asking in the fourth bit? In the fourth bit, what he is asking?
Power in watt and volt.
Power in watt and also power in volt ampere. What is the unit of S? Volt ampere. Unit of P is watt. Unit of Q is, what is the unit of Q?
VAR.
Volt ampere active. In the problem, he is asking the watts and VA. Therefore, S is equal to VI. Your V is 220. Your I is 6. That is your S. What is the other formula for S? I square Z. Your Z magnitude is 37. Verify it.
One 1320, sir.
1320 volt. Are you getting same answer here?
No, sir.
No.
1332, sir.
1332.
32. 32.
32 you are getting.
Yes, sir.
Actually, we have taken the 37 or something we are getting. 36.8 you have told. If you take that, you will get the same answer. Exact value you have not taken. Here we have rounded it off. 36 point something we got. If you take that value, you will get this value, 13.20. Okay. How much you got exactly Z magnitude? Magnitude of Z, exactly how much you got? Can you tell me? Magnitude of Z after converting into polar form. Z value. After converting into polar form.
36.89.
36.89.
Okay, 36.89, you take it and see how much you'll get here.
One three two 8.04, sir.
Sir, we are getting 1328.
8.0.
28.
1320,
1328. 8, sir.
1328. Okay, approximately how to get this answer? Same.
Sir, if we multiply 36 into 36.7, then we get 1321.2, sir.
How much you are taking here? 36 point?
If we take 36.7, we'll get 1321, sir.
Okay, actually I have to
1321.2.
take the exact value, 36.8 there. Approximately these two should be same. Okay, in exam we can take any formula. Don't take both. Exam take any formula, they'll give the approximately if you are getting the value, they'll give the full marks. Okay. Actually you have to get the same answer because both the formulas are same. Okay. Now see in your textbook what they have given. So this is the solution they have done in the textbook. Your Excel is they have given wrong here. This is Excel. Excel is 63 and XC is 32. This is Excel. Excel is 63 ohms. XC is 32 ohms. Your net reactance is XL minus XC, that is 31. Since XL is greater than XC, your circuit is inductive. Then Z is equal to square root of R square plus X square, that is 37. Magnitude is 37 they have given. Angle they have not calculated, only magnitude. Hypotenuse square is equal to side square plus side square they have taken here. Hypotenuse square is equal to side square plus side square. Current I is equal to V by Z. 6 ampere approximate. They have taken the approximate value. 6 ampere. And VR is 120. VL is 378. They have given wrong here. 6 into 63 is 378. 6 into 63 is 378. They have given wrong here. BC is 192. Your power is 1320. S value. Power in watts is 713 they have given. Whatever you have calculated, that is type. Power factor is cos phi, 0.54. That's all about the problem. In the next class, we will see one more problem in RLC. Then we will go for the parallel circuit. Until now, we have discussed only series circuits. After the in the next class, we will start the parallel circuits also. Okay, I will take the attendance now. Wait for some time.